All right, so let's look at those last couple of problems here. So a central limit theorem can be used to investigate unusual events. An usual event is one that occurs with a probability of less than 5%. So let's look at our first problem here. So the average number of pounds of meat that a person consumes per year is 218.4 pounds. Assuming that the standard deviation is 25 pounds and the distribution is approximately normal, find the probability that a person selected at random consumes less than 224 pounds per year. Now be careful, which Z formula are you going to use? So what information are we given that helps us identify, are we going population or sample? All right, so we look at some key things here to help us out with that. So the average number of pounds, right? So there's our mean. We get a standard deviation of 25. We're told it is approximately normal. So that's good. And then we are given our big piece of information, less than 224. And then as you notice, there is no sample size given. So we're just using our normal Z formula. So we get our mean was 218.4. Our standard deviation is 25. So then Z equals 224 minus 218.4 over 25, and that gives us a Z equals 0.22. All right, and then we'll fill this in here. We get 218.4 for the mean. All right, and then we're looking for less than 224, so it's about there, and less than is going to, and less than is going to go this way. So we know our answer is going to be greater than 50%. So let's go ahead and take that over to Staplet. And then remember, we're using normal distribution. So we had a mean 218.4 and a standard deviation of 25. And we wanted less than, so we want to the left of a value, and our value was 224. And then we get our Z-score, 0.22, which matches, and then area 58.86. All right, giving us that 58.86%, which is also the probability that a person selected at random consumes less than 224 pounds per year. All right, let's look at 14 now. So similar setup. Average number of pounds of meat that a person consumes per year is 218.4. Same standard deviation at 25. It is approximately normal. If a sample of 40 individuals is selected, find the probability that the mean of the sample will be less than 224. So a lot of this is exactly the same, with the one standout that a sample of 40 individuals is selected. So we're going to use sample now. And so our mean of our sample ends up being equal to our mean, which is 218.4. We have our standard deviation, which is 25. We have an N, our sample size, of 40. And then we have our standard deviation sample size. So we get 25 over the square root of 40, which is 3.953. And then we get our Z. It's 224 minus the mean, 3.953, and that gives us 1.42. Alright, so then labeling our mean at 218.4, doing our standard deviation marks out, and then we can see this time All right, that our 224 is a little further out. We still want less than, so we're still getting this amount. So we know our answer is going to be greater than 50% as well. Let's take that over to our staplet. So our mean was 218.4 again. Our standard deviation this time was 3.953. And to the left of our 224. So there's our z, our 1.417 or 42 rounded up, and we get an area of 92.17. Okay, so a lot bit greater, and we know, yeah, once we go out past one standard deviation, it starts increasing by quite a bit. Okay, and then 15, comparing the probabilities. Why do we get 58.86 to 92.17? Well, when you sample those 40, there's variation in our sampling distribution, right? And so then we could have sampled more people that tend to eat more pounds per year, as opposed to the population size in 13 there, which is going to be more consistent and accurate.